episode of Triple Sec channel. In this episode, I want to introduce Pcode intermediate representation. Let's first talk about what intermediate representation is. Intermediate representation, or IR, is a middle step between high-level code like C and a low-level machine code like assembly. IR is a universal language that different tools such as compiler or reverse engineering frameworks can use to understand, analyze, or transform code. Why do we need IR? Because we do have different architectures such as x86, ARM, and MIPS, and because these architectures are different, IR helps us to abstract away the architectural differences, and it provides a uniform language that compilers, decompilers, or reverse engineering frameworks can operate on. In assembly, each instruction is broken into multiple IR statements. So each assembly instruction is equal to one or more IR statements. Now let's talk about what is Pcode. Pcode is one of the intermediate representation which abstracts away architectural differences, and using Pcode, you can work across different architectures. As an example, you can see one of the Pcode IR statements in this example. There are three main components in Pcode: address space, var node, and operation. Address space is a block of memory like RAM, but it is generalized for use in Pcode. Every Pcode operation reads or writes data into some address space. We have different types of address spaces such as normal memory or RAM. We have CPU registers, constant values, and temporary variables or unique values. In this example, you can see register and constant as two types of address spaces. Var node is a chunk of data, and it holds the value inside one of those address spaces. So it actually contains the value in the specific address space. Pcode uses var nodes to hold values that it operates on. For example, you can see in this example that register 0x20 is a var node. You can see a format of a triple in which the first element is an address space, the second is an offset into the space, and the third one is a size. So actually, each register in Pcode assigns to a specific offset. For example, register RSI is defined with this offset 0x20. So register 0x20 is actually register RSI in Pcode. What is Pcode operation? Like instructions in assembly that we have operations and operands, Pcode is also it does have like operations. It's like a simplified machine instructions, and it usually contains multiple var nodes as an input, and optionally it produces a single output var node. So here, as you can see, it's the previous example that we saw. So int add here is a Pcode operation that operates on two var nodes, register constant, and it actually adds these two values, the value in the register and the constant value, and it stores the result value in this register. So now I want to show a practical example in Ghidra. So Ghidra uses Pcode IR statements for different analysis, such as for data flow analysis, and Ghidra use Pcode IR. So I want to show a practical example in Ghidra that how you can use like Ghidra's API to print Pcode IR statements. But before that, we should mention that there is two types of Pcode in Ghidra: instruction level Pcode and decompiler Pcode. So instruction level Pcode is a more low level and close to machine semantics, and it does not come in the SSA format, while decompiler Pcode comes on top of the decompiler interface. Actually, decompiler does some, generates a richer uh, analysis of the P code, and it comes into in an SSA format. So generally, for some analysis such as data flow analysis, we use the P code in the decompile on top of the decompiler interface. Um, in this slide, I use the term SSA. Now, I want to explain what SSA actually means. SSA form is a way of writing code so that each variable is assigned exactly once. As you can see in this example, we have integer x that assigns to value 5. Then we increment that, assigns to x, and again multiply that by 2 and assigns that value to x. So x just assigned 3 times in the left side. But in the SSA form, we have to assign each value just once. We show x1 equal to 5, then because we increment x1 and the value just changed, so we assigned it to another value x2 and so on. So this is what actually SSA means. Now I want to show you a practical example in Ghidra. Here I have two examples, practical examples in Ghidra that covers two types of P-code: raw instruction P-code and decompiler P-codes. So the raw instruction P-code is actually, as I mentioned before, it's more low level and close to matching code semantics. Here in this example, I wrote a script earlier to print the Pcode IRs for a specific function in this binary. Before going deep dive into this example, I want to mention that fortunately and recently, Ghidra comes with a built-in Python library PyGidra that you can actually simply by installing PyGidra as a standalone Python library, you can easily use that to write your Ghidra script in Python 3. So you don't have to use Ghidraton anymore, and it's pretty straightforward. The documentation is very straightforward. You can just simply install PyGidra, and as you can see, you can start it, and you can use it as you can see here. So if you are not familiar with how to write a code and how to write scripts in Ghidra, I would highly recommend you to watch the previous episodes of Triple Sec channel, and because you're gonna get familiar step by step how to write the script. But now I just want to, like, from high level mention that if you are really don't know how to write a script in Ghidra, and you are not familiar like which API, which function you can use, you can simply, as you can see here, print the type of that object to understand like which class it belongs to, and then go to Ghidra's documentation and understand like which functions you can get access to by having this object. I'll show you an example here. So if I just let me first comment this part of code. If I just simply run the script, you'll see that the type of the current program is Ghidra Program Database Program DB. If you simply just Google it, you can see the Ghidra's documentation here. And in Ghidra's documentation for API is very, um, is very complicated, and it covers everything. So you can actually uh, find is find all the functions that you need to get access using an object. You can see here that by using current program, you can have access to all these functions. And because I'm looking for a specific function inside the binary and I want to print the Pcode IRs for that specific function, so I need an API to get access to the list of functions in the binary. One of that's actually APIs is get function manager. After that, get function manager will return a function manager DB, and function manager DB will use get functions to get access to the list of functions. After having the list of functions, you can print the name of each function, and I randomly chose get image pixels 1 from this binary. So I just randomly choose this function because I want to show you like how Pcode IRs look like in practice. If the function name is equal to this value, then I will ask the program to return the instructions for this specific function. And for each instruction, I will get the address on mnemonic. And if I uncomment this part of code, you can see here that I request for getting Pcodes on top of each instruction. And then I print the Pcode for each Pcode ops. If I run the program again, you can see the corresponding IRs for each instruction. So as you can see, the one instruction can be equal to multiple IR statements. It can be equal to one or more IR statements. And this is the example of Pcode that comes on top of, directly comes on the instructions. It's actually a low-level Pcode. Now let's look at the decompiler Pcode, that the Pcode instructions that comes on top of the decompiler interface. So till now it's the same as before, but you have to define the decompiling interface, and you have to ask the program to decompile the function that we have, decompile it, and using like this API get high function, get access to the Pcode ops. And if I print that, it's gonna return all the Pcode IR for this specific function that comes on top of the decompilation. So if I run that, you'll see the list of all IRs that actually comes on top of the decompilation index. I hope that this video was useful for you, and thanks a lot for your attention.